In the previous classes, we discussed the concepts of logarithms in the chapter real numbers of class 10. In today's session, we continue the problems on logarithms and the problems which are very important from the examination point of view will be explained in today's session. Let us start our class. All students must concentrate and understand the concepts of mathematics. Let us start our class. Class 10 real numbers. The subtopic is logarithms. Logarithms. Exercise 1.5. We are doing exercise 1.5, page number 23. Page number 23. Seventh problem. If 2.3 raised to the power of x equal to 0.23 raised to the power of y equal to 1000, then find the value of then find the value of 1 by x minus 1 by y. So this is the problem. In the previous class, we discussed method 1 using algebraic method. So we have two methods. We discussed two methods for this problem. Method 1 is algebraic method. We discussed in the previous class. Now method 2, it is using logarithms. Method 2 using logarithms. In today's session, we discuss method 2. So first we note down the given data. What is given? 2.3 raised to the power of x equal to 0.23 raised to the power of y equal to 1000. It is given. Now we note down the given data. Given 0.23, 2.3 raised to the power of x equal to 0.23 raised to the power of y equal to 1000. Now we consider first and third, and next we consider second and third. So we note down, consider 2.3 raised to the power of x equal to 1000. This can be written as 10 power 3. Taking logarithms on both sides, taking logarithms on both sides, we can write log of 2.3 power x equal to log of 10 power 3. Now you should remember that the base is 10. The base is 10. So using this formula, using the formula, using log x to the power of n to the base a equal to n log x base a. Using this formula, let us compare this, the left hand side term. This is of the form log x to the power of n to the base a. So we can write in the form of n log x base a. We can write it as x log 2.3 base 10. This is equal to the right hand side term is also in the same form, log x to the power of n to the base a. So we can write it as 3 log 10 base 10. In the next step, we use the formula log a to the base a. Log a to the base a equal to, using log a to the base a equal to 1. Here log 10 base 10 equal to 1. We can write this step. Using this formula, we can write the right hand side equal to 3 multiplied by 1, and the left hand side we have 2.3. 2.3 can be written as 23 by 10. So on the left hand side we can write it as x multiplied by log 23 by 10 to the base 10. So again using the formula, using log x by y to the base a equal to log x to the base a minus log y to the base a. The left hand side term we have log 23 by 10 base 10. So this can be compared with log x by y to the base a. It can be written as log x base a minus log y base a. Hence, the left hand side term can be written as x multiplied by log 23 base 10 minus log 10 base 10. This is equal to the right hand side is becomes 3 multiplied by 1. It becomes 3. So you must understand this concept. On the left hand side we have log 23 by 10 to the base 10. It can be written as log 23 base 10 minus log 10 base 10. This is it. Now again we use the formula log a base a. Here log 10 base 10 we have, it can be written as equal to 1. So left hand side can be written as x equal to x multiplied by log 23 base 10 minus 1. This is equal to 3. Now we divide by 3x on both sides. Dividing by 3x on both sides. We get x multiplied by log 23 minus 1, this is base 10, by 3x equal to 3x by not 3x, 3 by 3x. Hence from this step we get log 23 base 10 minus 1 divided by 3 equal to 1 by x. So this is taken as 1. So this is 1. We consider this result as 1. Now we consider, let us say this, we considered the first term and the third term and we got the result. Now we consider the second term and the third term, that is 0.23 raised to the power of y equal to 1000. It can be written here so that it will be easier to us to compare the steps. Consider 0.23 raised to the power of y equal to 1000. This can be written as 10 to the power of 3. Taking logarithms on both sides, taking logarithms on both sides, we get log 0.23 raised to the power of y to the base 10 equal to log 10 to the power of 3 base 10. Now, using the formula, using log x to the power of n to the base a equal to n log x base a. Using this formula, we can write, let us observe this left hand side part. We have the left hand side part in the form of log x to the power of n to the base a, and it can be written as n log x base a. So we write y log 0.23 to the base 10 equal to the, now we consider the right hand side. It is also in the form of log x to the power of n to the base a, and it can be written as n log x base a. So we write 3 log 10 base 10. I am using the same method to find the results for part 1 and part 2. I am not changing any steps. Now, using the formula, using log a to the base a equal to 1, we can write log 10 base 10 equal to 1. In place of this, we can write 1, log 10 base 10 equal to 1. So, we can write the right hand side equal to, that is 3 multiplied by 1, and on the left hand side we have log 0.23. So 0.23 can be written as 23 by 100. Here also I will write it. 2.3 can be written as 23 by 10. Now, on the left hand side, we write y multiplied by log 23 by 100 to the base 10. I can write it. Now, using the formula log x by y to the base a, using log x by y to the base a equal to log x to the base a minus log y to the base a. Using this formula, this part log 23 by 100 can be written as, we can write the step y multiplied by, using this formula, we can write log 23 by 100 in the form of log 23 base 10 minus log 100 base 10. This is equal to, on the right hand side we have 3 multiplied by 1. So we can write it 3. In the next step, we write it y multiplied by log 23 base 10 minus 100 can be written as 10 square. 100 can be written as 10 square. So we can write log 10 square to the base 10. Log 10 square to the base 10 equal to 3. Now using the formula, using using log x to the power of n to the base a equal to n log x to the base a, using this formula we can write log 10 to the power of 2 base 10 as 2 log 10 base 10. We can write it. So we now use the formula y multiplied by log 23 base 10 minus 2 log 10 base 10 equal to, on the right hand side we have 3 only. We are not changing the value. So this is taken as 1. Now in place of log 10 base 10 we can write 1 using log a base a equal to 1. Using this formula we can write log 10 to the base 10 equal to 1. So we can write y multiplied by log 23 base 10 minus, this is 1. We can write it 2 multiplied by 1. 2 multiplied by 1. This is equal to 3. Therefore, therefore y multiplied by log 23 base 10 minus 2 equal to 3. Now we divide both sides by dividing both sides by 3y. Dividing both sides by 3y, we get y multiplied by log 23 base 10 minus 2 by 3y equal to 3 by 3y. On cancellation, we get log 23 base 10 minus 2 by 3 equal to 1 by y. So this is taken as 2. So this is taken as 2. So from 1 and 2, we write now from 1 and 2, 1 by x minus 1 by y equal to 1 by x, its value is log 23 base 10 minus 1 by 3 minus 1 by y. Its value is log 23 base 10 by 3. This is minus 2. We have these values. So we can write 1 by x minus 1 by y equal to log 23 base 10 by 3 minus 1 by 3 minus log 23 base 10 by 3 plus 2 by 3. Now on cancellation, we get after simplification of this right hand side, we get 1 by x minus 1 by y equal to 1 by 3. Hence, hence 1 by x minus 1 by y equal to 1 by 3. Therefore, the result is proved. Let us discuss this concept briefly. In the previous class, we discussed algebraic method to find to show that 1 by x minus 1 by y equal to 1 by 3. So let us see method 2. Method 2 is using logarithms. We first consider, I will try to explain the both the steps. Now, on the we have considered 2 point this given data 2.3 power x raised to the power of x equal to 10 power 3. Here also we have written the first step. Second and the third are considered on the right hand side. Next step, taking logarithms on both sides. So here also we have written taking logarithms on both sides. We are comparing both the steps. So we can write log 2.3 power x base 10 equal to log 10 power 3 base 10 using taking logarithms for this on both sides. We write log 2.3 power x base 10 equal to log 10 power 3 base 10. Now we observe the right hand side of the terms also. Taking logarithms for this, we get log 0.23 raised to the power of y base 10 equal to log 10 power 3 base 10. So on the left hand side and the right hand side, we follow the same procedure. Students must understand this concept. For simplicity purpose, I am explaining both sides at a time. There are no changes. Now this is in the form of log x to the power of n to the base a, and the right hand side term is also in the form of log x to the power of n base a. So we can write it x x log a base a, x n log x base a. So using this formula, we have written this step as x log 2.3 base 10, and this can be written as 3 log 10 base 10. Using the formula log x to the power of n to the base a equal to n log x base a. Now you observe the steps on the right hand side. Here also this is in the form of log x to the power of n to the base a. So we can write this step using this formula log x to the power of n to the base a, and the right hand side term here also is of the form log x to the power of n to the base a. So we can write 3 log 10 base 10 here. On the left hand side we can write y log 0.23 base 10. Now on the right hand side we have log 10 base 10 here. So using the formula log a to the base a, we can write it 1 3 multiplied by 1. We can write 3 multiplied by 1 on the right hand side. So using the formula log a base a. Here on the right hand, here also log 10 base 10 we have. In place of log 10 base 10 we can write 1. So 3 multiplied by 1, it can be written using the formula log a base a. Now the left hand side term is in the form of log x by y to the base a. It can be expanded as log x to the base a minus log y to the base a. Using this formula, I have written this step on the left hand side. That is log 23 by 10 base 10 equal to log 23 base 10 minus log 10 base 10. This step is written. Here also log 23 by 100 base 10. It is in the form of log x by y to the base a. So it can be expanded as log x base a minus log y base a. So log 23 base 10 minus log 100 base 10. No changes in the steps. Both sides The simplification part is the same. Now, here we should write one step using using log a to the base a equal to 1. Using log a equal to base a equal to 1, in place of log 10 base 10, we can write 1. In place of log 10 base 10, we can write 1 using the formula log a base a equal to 1. Log a base a equal to 1. So this is how we got 1 here. Log 10 base 10 is written equal to 1. So now we consider the right hand side part. Log 100 to the base 10. 100 can be written as 10 square. So in place of 100, we have written 10 square. In place of 100, we have written 10 square. It is using the formula log x to the power of n to the base a equal to n log x base a. This is compared with the formula log x to the power of n to the base a. So log 10 square to the base 10 can be written as 2 log 10 base 10. Log 10 square base 10 can be written as 2 log 10 base 10. Again, we use the formula log a base a equal to 1 on this log 10 base 10. So log 10 base 10 equal to 1. Hence, we can write 2 multiplied by 1 here. So we get 2. Now, let us see this here. On the left hand side, we have this step, and the right hand side, we have this step. You observe these two steps. After this, steps, dividing by 3x on both sides. Dividing by 3x on both sides, we get this result. Log 23 base 10 minus 1 by 3 equal to 1 by x. After this step, x multiplied by log 23 base 10 minus 1 equal to 3, dividing on both sides by 3x. Now, so on the right hand side also, we have written the step dividing both sides by 3y. Dividing both sides by 3y. Dividing both sides by 3y, we get the results. Log 23 base 10 minus 2 over 3 upon 3 equal to 1 by y. So this is taken as second 2, equation 2. From equation 1 and equation 2, we can write here 1 by x minus 1 by y. In place of 1 by x, I have written its value, and in place of 1 by y, we have written its value. Now expanding this equation, we get log 23 base 10 upon 3 minus 1 by 3 minus log 23 base 10 over 3 plus 2 by 3. Simplifying this, we get 1 by x minus 1 by y equal to 1 by 3. This is the result. Dear students, you have learned both the methods. In both the methods, 1 by x minus 1 by y equal to 1 by 3. We proved the result. So what I suggest to all the students is to understand the concepts and according to the question in the examination, you will have to answer to the given question. It is left to your choice. If you understand, you must follow any one of the methods which are logically correct and mathematically correct. They can be written in the public examination of class 10. And remember, there are several methods to solve the problems. I am explaining only two methods, not explaining all the methods for all the problems. I am considering only two methods. Now, we have ninth problem. Is number 1, log 2. Log 2, it means log 2 base 10. Log 2 base 10, rational or irrational? Rational or irrational? Justify your answer. Justify your answer. The second question. Log 100 to the base 10. Rational or irrational? Rational or irrational? Justify your answer. Now let us consider log 2 base 10. Log 2 base 10. This is answer for first problem. Log 2 base 10. Let us consider, let x equal to log 2 base 10. By definition of logarithm, by definition of logarithm, a to the power of x equal to n implies and implied by x equal to log n to the base a. This is the definition of logarithm. First, we have considered log 2 base 10 and it is taken as x. Now, this is in this form x equal to log n base a. Then it can be written by the definition of logarithm as a to the power of x equal to n. Now, here let us compare this with in place of x we have x, in place of n we have 2, in place of a we have 10. Dear students, one of the student asked one question in the previous class, which we discussed in the previous class. 152.888, that means 152.89 bar 88 bar, otherwise 152.8 bar. So this can be written as 152.89. Here 152.888 and so on. So we can write it as 152.89. So this is the correct answer. This is if it is more than 5, then we consider the next number. So that is why here I have written 152.89 bar in a statistics class. It is the right answer. Now let us come to this discussion. We can write this form a to the power of x equal to n. What is a? A equal to 10, n is 2, x is in place of x we can write x. So by this we can write 2 to the power of x equal to 10. 2 to the power of x equal to 10. So here I can write it as 2 raised to the power of x equal to 10 to the power of 1. So this is impossible. This is impossible. Here let us consider some examples for 2. 2 to the power of 0 equal to 1. 2 to the power of 1 equal to 2. 2 square equal to 4. 2 cube equal to 8. 2 to the power of 4 equal to 16. 2 to the power of 5 equal to 2 to the power of 5 equal to 32. I can write it here. 2 to the power of 5 equal to 32. 2 to the power of 6 equal to 64. 2 to the power of 7 equal to 128. 2 to the power of 8 equal to 256. 2 to the power of 9 This is equal to 512. 2 to the power of 10. This is equal to 1024. 2 to the power of 11. This is equal to 2048. 2 to the power of 12 equal to 4096. Why I explained up to this now? Why? Because if you observe the units digit, here is 2, 4, 8 and 6. Here also units place is 2, 4, 8, 6. I am talking about the units place only. Now, here the units place is 4. Here units place is 2. So, let us observe this. So, 2 to the power of n ends with the digits if n is greater than 0. If n is if so I will write it. If n is a natural number, otherwise if n is any integer, then 2 to the power of n ends with I will write not z, it is whole numbers. Then 2 to the power of n ends with 2, 4, 6, 8 in units place. This is very important concept. You must understand this. If n is a natural number, then 2 to the power of n ends with 2, 4, 6 or 8. I will write R8 or 8 in its units place. Here 10 ends with 0 only. We consider now the examples for 10. Let us consider this. 10 power 1 equal to 10. 10 square equal to 100. 10 cube equal to 1000. 10 power 4 equal to 10,000. So if we discuss this and so on, so 10 power n ends with 0. If n is any natural number, if a small n is any natural number, if a small n is any natural number, then 10 to the power of n ends with the digit 0. Whereas 2 to the power of n ends with the digits 2, 4, 6, 8. So all these points need not be written in the examination. I am explaining these concepts only to understand. So these steps need not be written. So I am writing these steps in boxes. You don't write in the examination. This concept is explained just to understand. So now let us discuss. Let us come to a discussion. 2 to the power of x equal to 10. 2 to the power of x. 2 to the power of x equal to 10. is impossible. Because why? Because we write that step number 1. If n belongs to natural number, if n is a natural number, 2 power n ends with 2, 4, 6 or 8 in units place. And number 2, if n is a natural number, small n is a natural number, then 10 to the power of n ends with 0 in its units place. Actually, here in this problem, we need not write 10 to the power of n. Why? Because we have 10 only. You just observe this. We need not write. We need not write 10 to the power of n here. But I am explaining concept. That is why I have written 10 to the power of n. So, therefore, here we should write where here log 2 base 10. What is the value of log 2 base 10? It is a positive only. That is why x should be taken as a positive real number. X is a positive real number. In other words, we can write it r plus, where x is r plus. R plus means positive real numbers. R plus. R plus means positive real numbers. Here 2 to the power of x equal to 10, it is impossible to write this step. So we have written this part. Okay, now this step 2 power x equal to 10 is impossible. It is very clear. Now suppose that suppose that suppose that log 2 base 10 is a real number. Log 2 base 10 is a real number. If log 2 base 10 not a real number, rational number, is a rational number. If log 2 base 10 is a rational number such that log 2 base 10 equal to x by y, where number 1, x and y are integers and x not equal to 0, y not equal to 0. Why? Because here log 2 value is not equal to 0. Okay, we need not write here x not equal to 0. Just we simply write the definition of integer y is not equal to 0. And the second consideration is that highest common factor of x and y equal to 1. That is x and y are co-primes. X and y are co-primes. If x and y are co-primes, now here by definition of logarithm, by definition of logarithm, we can write 2 equal to 10 to the power of x by y. Here that is a power x equal to n, implies and implied by x equal to log n base a. Now from this step, raising to the power of y on both sides. Raising to the power of y on both sides, we can write 2 to the power of y. We can write 2 to the power of y equal to 10 to the power of x by y whole to the power of y. So this is equal to 10 to the power of x by y multiplied by y. From this, we can write 10 to the power of x. Here 2 to the power of y. So here in the above, we have proved that 2 to the power of x is not equal to 10, and also 10 power n. 2 power x cannot be written, cannot be equal to in the above step. We proved that 2 to the power of x cannot be equal to 10. Hence 2 to the power of y, this can be written as this cannot be equal to 10 to the power of x. Therefore our assumption is wrong. Hence our assumption that log 2 base 10 is rational, is wrong. So if it is not a rational number, then we write the definition of irrational number. A real number, a real number which is not rational is called an irrational number. Therefore, therefore, log 2 base 2 is irrational. Here, what all of you should remember is yeah, here the base for this problem is 10. A is 10. What should you remember is so actual problem starts from this step. Suppose that, but I would like to prove that 2 power x cannot be written in the form of 10. That is, it cannot be equal to 10. If it is not equal to 10, 10 power n is also not possible. 10 power n is also not possible. That is why we have written all these steps. So I would like to explain this briefly. Log 2 base 10. Suppose that for any real number x, log 2 base 10 is taken as x. So by the definition of logarithm, that is a power x equal to n implies and implied by x equal to log n base a, we can write x equal to log 2 base 10 as 2 to the power of x equal to 10. Now let us check whether it is possible or not. Here we consider various examples: 2 to the power of 1, 2 square, 2 cube, 2 power 4, up to 2 to the power 12 we have considered. We have observed that if n is a natural number, then 2 to the power of n ends with 2, 4, 6 or 8 in its units place. And 10 10 to the power of n ends with 0 in its units place. These are our observations. So based on these observations, what we can write is 2 to the power of x equal to 10 is impossible. This is impossible. I have written the reason why it is impossible. Why? Because 2 power x ends with the digits 2, 4, 6 or 8 in its units place, whereas 10 ends with the digit 0 in its units place. So this is impossible. Hence, we can conclude that 2 cannot be 2 to the power of x cannot be expressed in terms of 10. Now let us consider the proof part. Suppose that log 2 base 10 is a rational number. If log 2 base 10 is a rational number, then we can express it in the form of x by y, where the first condition x and y are integers and y is not equal to 0. Y is not equal to 0. And the highest common factor of x and y equal to 1. It is very clear to us that it is a positive value. Log 2 base 10 is a positive value. So that is, it is a positive real number. It is very clear, log 2 base 10 is a positive real number. That is, x by y is a positive real number. It is very clear. Now what we have to explain is whether it is a rational number or irrational number. That is the question. Whether it is a rational number or irrational number. If it is a rational number, then we can express it in the form of x by y. Let us say this. By the definition of logarithm, log 2 base 10 equal to x by y can be written in this form by using the definition of logarithm. A to the power of x equal to n implies implied by x equal to log n base a. So now, raising to the power of y on both sides, this step can be written as 2 to the power of y equal to 10 to the power of x. But 2 to the power of any n cannot be equal to 10 to the power of m for any value. So why? Because 2 to the power of n cannot be expressed as 10. We discussed the reason in the above. So in the above step, we proved that 2 to the power of x cannot be equal to 10, and hence 2 to the power of y cannot be equal to 10 to the power of x. This is impossible. So we got this contradiction. Here we should write a step. We got this contradiction. We got a contradiction to the fact that 2 to the power of y is not equal to 10 to the power of x. We got that 2 to the power of y equal to 10 to the power of x. But it is not true. We have already proved that 2 to the power of y cannot be equal to 10 to the power of x. 2 cannot be expressed in terms of 10. 2 to the power of n cannot be equal to 10. So this contradiction is because of a wrong assumption. So log 2 base 10 is not a rational number. If this is not a rational number, then should be an irrational number. This is why, because a real number which is not a rational number is called an irrational number. By the definition of irrational number, log 2 base 2 is a irrational number. Now we consider the second part. What is the second one? Log 100 to the base 10. Now log 100 to the base 10, this is equal to log 10 square to the base 10. Using log x to the power of n to the base a equal to n log x base a. Using this formula on this part, right hand side part, we can write it as 2 log 10 base 10. On the left hand side, we write log 100 to the base 10. So this is equal to, again, using the formula, using log a base a equal to 1, we can write log 10 base 10 equal to 1. This can be written. So we get the right hand side 2 multiplied by 1. On the left hand side, log 100 to the base 10. So it is equal to 2. 2 is a rational number. Therefore, since since 2 is a rational number, why it is a rational number? Log 2 log 100 log 100 base 10 equal to 2 is a rational number. Why the 2 is a rational number? 2 can be written as 2 by 1. So this is in the form of P by Q. This is in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is the definition of rational number. This is the definition of a rational number. Right. Now, the exercise 1.5 is complete. Exercise 1.5 is complete. We are considering optional exercise. Optional exercise. For practice purpose, we are solving some more problems in this real number chapter. Page number 23. Page number 23, class 10, real numbers. The first problem. Can the number 6 to the power of n being a natural number, n being a natural number, end with the digit 5, end with the digit 5. Give reason. Give reason. This is very simple problem. Let us consider some examples to understand this concept. 6 to the power of 1 equal to 6. 6 square equal to 36. 6 cube equal to 216. Now we consider 6 power 4. This is 1296. 6 power 5. This is equal to 7796 and so on. So if you observe this, you can find that 6 ends with the digit 6 only. 6 ends with the digit 6 only. So it never ends with that is it 5. Now we have understood the concept, but how to conclude that 2 power 6 power n does not end with digit 5 mathematically? We require the mathematical proof. This is okay. This is just to understand the concept. Now, what is the mathematical proof for that one? So we write this step first. 6 equal to 2 multiplied by 3. 6 equal to 2 multiplied by 3. So in the next step, let n is a natural number. N is a natural number. Then we can write 6 to the power of n equal to 2 multiplied by 3 whole power n. This can be written as 2 to the power of n multiplied by 3 to the power of n. Two to the power of n and 3 to the power of n. So here we used the formula axy 2 to the power of xy to the power of n equal to x to the power of n multiplied by y to the power of n. This is the formula. We used this formula. Using this formula, we can write this step. So I write this step here. Using xy whole to the power of n equal to x to the power of n y to the power of n formula, 6 power n equal to 2 to the power of n multiplied by 3 to the power of n. So since 2 and 3 are prime numbers, since 2 and 3 are prime numbers, and 5 is also a prime number, a prime number, we get 5 does not divide 2 to the power of n, and 5 does not divide 3 to the power of n. This is because we should write a step here. 5 does not divide 2, that implies 5 does not divide 2 to the power of n, and this is also 5 does not divide 3 implies 5 does not divide 3 to the power of n. Hence, from these two steps, we can conclude this implies 5 does not divide 2 to the power of n multiplied by 3 to the power of n. So this implies that 5 does not divide 6 to the power of n. So this is first one we have given, but the given question is not regarding the divisibility of 5. They simply asked whether 6 to the power of n ends with 5 or not. So this is I have given you the information regarding the divisibility by 5. So now I would like to answer to the question whether 6 power n ends with the digit 5 or not. Let us discuss this. Now this is the answer to the question. This is the answer. 6 equal to 2 multiplied by 3, and 6 to the power of n equal to 2 to the power of n, 2 multiplied by 3 whole to the power of n, that equal to 2 to the power of n multiplied by 3 to the power of n. Here 2 to the power of n, 2 to the power of n does not end with digit 5, and also 3 to the power of n, 3 to the power of n does not end with digit 5 in its units place, in its units place. So 2 to the power of n multiplied by 3 to the power of n does not end with digit 5 in its units place. So 2 to the power of n multiplied by 3 to the power of n is nothing but 6 power n. 6 power n does not end with digit 5 in its units place. So what this is the conclusion. We have given the reason also. So I have given this is part 2. This is the actual answer to the given question, part 2. This is the actual answer. And here if another question is given the divisibility by 6 power n, so and here I would like to add another problem. This is to check whether 6 power n is divisible by 5. Divisible by 5. So for that 6 equal to 2 multiplied by 3 implies, so this is part 2. Part 2 answer. I will note down this as part 1. So I did two problems, that is divisibility by 5, and the second one is the law units digit ends with unit digits of 6 power n ends with 5 or not. So this is the mathematical proof for this. Now we consider another simple problem. I would like to end this chapter tomorrow. This is third problem. Is 7 multiplied by 5 multiplied by 3 multiplied by 2 plus 3. I will write it in other, plus 3, a composite number. A we are conducting classes at 2:30 p.m. This is statistics. And at 5:30 p.m. We are conducting a class for real numbers. So if you are interested to learn just one thing. So we are conducting classes for class 10. For class 10, this is first class and second class. We are conducting statistics and real numbers, two chapters simultaneously. So you can attend and so that we can complete the syllabus as early as possible. Now, after the completion of real numbers tomorrow real numbers chapters will be completed. After this, I will consider another chapter. Dear students, I would like to utilize the time properly so that maximum syllabus can be explained within the short time. All students will be able to understand the concepts, mathematical concepts in the better way, and you will be able to revise the concepts as early as possible. So you can prepare for public examination of class 10 very well. Dear students, you start preparing for the examination from the starting concepts only. You start preparation now. From today onwards, if you start your preparation, it will be easy to appear for the public examination of class 10. Thank you all students. Thank you very much.